This planet orbits a dead star so closely that by every old rule, it should not still exist. A world roughly the size of Jupiter circles the burnt-out core of a once sun-like star every 1.4 days. That is not just unusual, it is almost rude to everything astronomers thought should happen after a star dies. The planet is called WD 1856 plus 534b. The dead star it crosses is a white dwarf, a stellar ember about the size of Earth, but packing roughly half the sun's mass. And the central mystery is simple. How did a giant planet end up in a place where the dying star should have swallowed or shredded it first? That question is bigger than one planet. It reaches straight into the future of our own solar system. Because one day, the sun will become this kind of corpse too. Start with the dead star itself. A white dwarf is what remains after a star like our sun runs out of fuel, swells into a red giant, then blows off its outer layers. What stays behind is a core so dense that a spoonful would weigh tons on Earth. Tiny, faint, ancient-looking, but gravitationally vicious up close. In 2020, a team led by Andrew Vanderberg reported in Nature that this planet was found transiting the white dwarf WD 1856 plus 534 using data from NASA's TESS mission, with follow-up from the Spitzer Space Telescope and ground observatories. The numbers were stunning. The white dwarf is about 80% the mass of the sun. The planet's orbital period is just 1.4 days. Its orbit is only about 0.02 astronomical units from the star, around 50 times closer than Earth is to the sun. And that is the problem. When the original star expanded into a red giant, its outer atmosphere would have stretched far beyond that distance. So if the planet had always been there, it should have been engulfed, gone, vaporized. Maybe not instantly, but dragged, heated, and very likely destroyed. So astronomers had to consider an uncomfortable possibility. The planet was not born there. It moved there later. This is where the mystery turns elegant. A giant planet can survive stellar death if it starts far away. When the star loses mass, the orbits of distant planets drift outward. The whole system loosens. It becomes dynamically fragile. Then gravity starts playing a slower, stranger game. Other bodies, maybe companion stars, maybe additional planets, can disturb the giant planet's path over millions or billions of years. Its orbit becomes stretched, tilted, chaotic. Then, each close pass near the white dwarf lets tides drain orbital energy until the planet settles into a very tight circle. In other words, WD 1856 plus 534b may be a refugee. Not a native of that scorching orbit, but a survivor thrown inward after the explosion had already ended. Excited. One leading idea involves what astronomers call high eccentricity migration. It sounds technical, but the picture is vivid. Imagine a skater pulled from a wide arc into a narrow spin. Only in space, the pull comes from gravity, and the time scale is cosmic. The planet likely began several astronomical units away. Then interactions with other objects pumped up its eccentricity until it skimmed the white dwarf. Tidal forces did the rest. there is evidence the system had the right ingredients for this. WD 1856 plus 534 is part of a wider triple star system. 2 dim red dwarf companions orbit much farther out. Their gravity could have helped destabilize planetary paths through processes like Kozai-Lidov oscillations, where a distant companion slowly twists in orbit until it becomes extreme. It is a beautiful mechanism, and a ruthless one. Beautiful, because it explains survival. Ruthless, because survival here does not mean comfort. This world receives intense irradiation from a stellar corpse and circles it at a distance that, on a human scale, feels obscene. So, let me ask you something. What's more astonishing to you? That a planet can survive the death of its star? Or that gravity can rearrange a whole planetary system billions of years later? Tell me in the comments. But there is another layer to the puzzle. The planet seems to be no more than about 14 Jupiter masses, based on observational limits from the 2020 Nature paper and later analysis. That matters, because if it were much more massive, it could be a brown dwarf, almost a failed star. Instead, it appears to be a genuine planet, a giant one, yes, but still a planet that somehow crossed the graveyard and kept orbiting. And astronomers have reasons to care beyond the drama of this one system. White dwarfs are not quiet museums. Many show signs of planetary wreckage. Roughly 25 to 50% of white dwarfs display heavy elements in their atmospheres, according to studies including work by Boris Gansike and colleagues. That is weird, because those elements should sink quickly out of sight. If they are still there, something must be feeding the star. Probably disrupted asteroids, minor planets, cosmic debris. So the broad picture is this. Planetary systems do not simply end when the star dies. They become unstable. They scatter. They cannibalize themselves. And occasionally, one survivor ends up in a place no one expected. Personally, this is the part I can't get over. We tend to imagine the stellar death as a clean ending, one bright catastrophe, then silence. But systems like this suggest something messier and, honestly, more haunting. Death is not the end of the choreography. It is when the strangest steps begin. Mini-hook. And what astronomers found next made this planet more than a curiosity. It became a test case for whether dead stars could still host worlds worth studying. Because a white dwarf has one enormous advantage. It is small. Really small. About Earth-sized. That means when a large planet passes in front of it, the transit signal is huge compared with transits around normal stars. This is one reason WD 1856 plus 534b stood out so clearly in test data. And it raises a wild possibility. If smaller planets also survive or migrate inward, we might someday detect rocky worlds around white dwarfs with extraordinary precision. But wait, there's a twist nobody should ignore. WD 1856 plus 534b is probably too cool, too massive, and too difficult for current instruments to reveal a thick atmosphere in detail. So the most important thing about this planet may not be the planet itself. It may be what it proves can happen. If a Jupiter-sized world can move inward and survive, then smaller rocky planets might do it too. Or they might form from leftover debris. And if that's true, the search for habitable worlds after stellar death stops sounding like science fiction starts sounding like a roadmap. Researchers like Avi Loeb and others have discussed the possibility of habitable zone planets around white dwarfs for years. The habitable zone there would be incredibly close in, on the order of hundredths of an astronomical unit. Tiny, tight, precarious, yet stable enough in principle for liquid water if the timing and migration history are right. Can you imagine that? A world getting a second chance beside the ember of a dead sun? My opinion is that this is why WD 1856 plus 534b matters so much. Not because it is cozy, not because it is likely inhabited, but because it breaks the old mental model that stellar death erases planetary futures. It doesn't. It reshuffles them. And if that idea surprised you as much as it surprised me when I dug into the mechanics, leave a like, because this single system may be the clearest hint yet that planetary afterlives are real. Now bring this back home. In about 5 billion years, the sun will swell into a red giant. Mercury and Venus are almost certainly doomed. Earth is in trouble too. Whether it is engulfed or merely scorched into a lifeless cinder depends on details of solar mass loss and tidal interaction that astronomers still debate. The outer planets survive. Their orbits expand. The architecture loosens. Then, imagine Jupiter, Saturn, or some icy moon-bearing world in a system no longer anchored by a stable, massive sun. Gravitational nudges accumulate. Resonances shift. Distant bodies stir the survivors. Over immense stretches of time, a world could migrate inward toward the sun's future white dwarf remnant, just as this planet seems to have done. Confesso que quando penso nisso, a escala me desmonta pouco. Everything we call permanent, sunrise, seasons, the rhythm of planets, is temporary. But the universe is not only good at destruction, it is good at rearrangement. That may be the deepest insight here. WD 1856 plus 534b is not just an oddball. It is evidence that cosmic endings can create new orbital stories. A system can pass through fire and still keep writing chapters. So maybe the real mystery was never how this planet survived. Maybe it's how many others did. Unseen, colder, circling stellar ashes in the dark, waiting for us to notice. And if one giant world could dodge destruction, migrate inward, and park itself beside a dead star, what else is out there? How many future Earths, future ruins, future second chances are orbiting white dwarfs right now? If the idea that worlds can outlive their suns expands your sense of the universe, subscribe and join the curious minds following this channel. Because out in the dark, the endings are rarely the end.